In this video, I'm going to go through the solutions to my 2025 AQA Paper 1 Higher practice paper. Before watching the video, I would highly recommend that you download a copy of the paper and try it yourself. You can get a free copy of it from my website, and there's also a link in this video's description. Just before I run through the answers, a brief disclaimer. This paper has been made using some of the most frequently occurring topics from past papers, but you should still not consider it a predicted paper. Nobody can predict what topics are going to come up. If you see creators going on about how accurate their predictions were last year, then this is them simply trying to get you to pay for their paper. You should, however, make use of past papers and practice papers to support your revision, but if you truly want to succeed in maths, you need to be prepared for all of the topics. You don't need to spend any money to do this either. There are plenty of free videos, papers, and booklets all over the internet that you can use. In this question, we're told that A is 5% greater than B. If you increase something by 5%, then you could say it's 105% of the original value. A decimal multiplier for 105% is 1.05, since if you divide 105 by 100, you get 1.05. This means to get A, we could multiply B by 1.05. So the correct number to complete the equation below is 1.05. In this question, we need to do 8 divided by 2/3. The first thing we're going to do is write 8 in a fraction form, which will just be 8 over 1. We then change the divide to a multiply, and take the reciprocal of the second fraction, so instead of 2 over 3, 3 over 2. Now we can just multiply these fractions together. 8 multiplied by 3 is 24, and 1 multiplied by 2 is 2. This is just 24 over 2, or 24 divided by 2, which is 12. So the answer is 12. In this question, we have a straight line that has this equation here, and we need to work out the coordinates of where it crosses the y-axis. Any point that has a coordinate on the y-axis has the x-coordinate 0. So if we take the equation of the graph, we can just substitute x for 0 to find the y-coordinate. So we write it out again, y equals 4 lots of x, but we're going to substitute x for 0, so 4 lots of 0, subtract 8, which is y equals 4 lots of 0 is just 0, so 0 subtract 8, and 0 subtract 8 is negative 8. So we find that when we substitute x for 0, we get y as negative 8. This means the coordinate must be 0 for x, and negative 8 for y. For the second part of the question, we need to work out where it crosses the x-axis instead. Any points on the x-axis have the y-coordinate 0, so we'll take the equation again, but we'll substitute y for 0 this time. This leaves us with an equation to solve. We can first of all add 8 to both sides. If you add 8 to the left, 0 plus 8 is just 8, and on the right the 8 will cancel the subtract 8, so we just have 4x. Then we can divide both sides by 4, 8 divided by 4 is 2, and 4x divided by 4 is 1x, so we find that x must be equal to 2. So the coordinates where it crosses the x-axis are 2 for x, and 0 for y. In this question, we need to solve this inequality. We'll start by subtracting 4 from both sides. On the left-hand side, the 4's will cancel, so we just have 2x. And on the right-hand side, negative 2 subtract 4 is negative 6. Then we can divide both sides by 2. On the left-hand side, 2x divided by 2 is 1x, and on the right-hand side, negative 6 divided by 2 is negative 3. So this is the solution, x is greater than negative 3. For the second part of the question, we need to represent the previous part's answer on this number line below. So that's this inequality here. We start by drawing a circle at the number in that inequality, negative 3. We then need to decide if we're going to leave this circle open or shade it in. Since the symbol is a greater than, we will leave it open. Had it been greater than or equal to, we would have done a shaded circle instead. Then we need to draw an arrow to represent the direction of the numbers that are greater than negative 3. This would be to the right, since all of these numbers here are greater than negative 3. For example, 1 is greater than negative 3. In this question, we need to find the nth term of this sequence. We'll start by working out the difference between each of the terms. To get from one term to the next in this sequence, you always add on 0.5. This means the nth term will start with 0.5n. Then we need to write out the multiples of 0.5, so 0.5, 1, 1.5, 2, 2.5, and so on. Then we just work out how to get from the multiples of 0.5 to our sequence. For the first term here, we would need to add on 1.5. And that's the same for the next one. And in fact, that's the same for all of them. So we take 0.5n and then we just add on 1.5 to get our sequence. So the nth term is 0.5n plus 1.5. In this question, we need to work out the volume of a prism. This is actually a formula from your formula sheet. It will say the volume of a prism is the area of the cross-section multiplied by the length. So we need to start with the area of the cross-section. We're told in the question the cross-section of this is a right-angled triangle. So let's find the area of this right-angled triangle. To do that, we do 1/2 multiplied by the base, which is 3, multiplied by the perpendicular height, which is 4. To work this out, we'll start with 3 times 4, which is 12, and then do a half of this. Half of 12 is 6. So the area of the triangle is 6 centimeters squared. The formula then says we need to multiply this by the length. The length of this prism is 7.5. So we take this 6 and multiply it by 7.5. To work this out, I would do 75 multiplied by 6 instead. 6 5s are 30, and then 6 7s are 42, and if we add this 3, we get 45. So 75 multiplied by 6 is 450. But we want 7.5 multiplied by 6, which is 10 times smaller, so it will be 45. And that's the answer to the question. In this question, we're told about the mass of a banana, which is 120 grams to the nearest 10 grams, and we need to work out an error interval. To do this, I draw a number line and place the number from the question, 120 grams, in the middle. We then need to consider what it could have rounded to the nearest 10 grams above and below this number. To the nearest 10 grams below, that would be 110. The nearest 10 grams above would be 130. We find the bounds of the error interval then by finding the points halfway in between these numbers. Halfway in between 110 and 120 is 115, and halfway in between 120 and 130 is 125. So these numbers form the bounds of the error interval, 115 and 125. In this question, Serena selects 4 different prime numbers less than 30, so let's write out all of the prime numbers less than 30. We're told the median of her 4 prime numbers is 15, so if we draw out 4 lines to represent the 4 prime numbers, let's just say, for example, we take the first 4 of these, 2, 3, 5, and 7. To find the median, we're looking for the one in the middle. So here we would cross off the 2 and the 7, and we're left with 2 middle numbers, 3 and 5, so the number halfway in between those would be the median, which in this example is 4. But we want a median of 15. There are actually a few different ways you can choose your middle numbers to get a median of 15. One would be to choose 13 and 17, because halfway in between these is 15. You can check this because if you add them together, you get 30, and if you half that, you get 15. We could also use a different example though. We could use 11 and 19. If you add these together, you also get 30, and half that will of course give you 15. And there's even one more. We could use 7 and 23. Now we'll consider the next statement. The range of her 4 prime numbers is 12. This means the difference between the greatest and smallest number must be 12. Let's work with the bottom example here. There's only one more prime number left greater than 23 that we can use, which is 29. And if we choose the number immediately below 7, so 5, the difference between these two is 29 take away 5, which is 24. So that range is far too big. And even if we change that 5 to a 3 or to a 2, the range will actually increase. So we can't use this bottom set of numbers at all. Let's try the next setup with 11 and 19 in the middle. The number that's immediately greater than 19 is 23, and the number immediately below the 11 is a 7. The range is the difference between these two, 23 take away 7, which is 16, so that's too big. And again, if we change these numbers, we'll just start to increase the range, so this one doesn't work either. So we must use the 13 and the 17 in the middle. If we place a 19 at the top and an 11 at the bottom, the range here is now too small. 19 take away 11 is 8. So if we change that 11 to a 7, the range becomes 19 take away 7, which is 12, which is the number we wanted. So this is one possible set of numbers for your solution. 7, 13, 17, and 19. There is one other possible solution. If you put an 11 at the bottom and a 23 at the top, the range here is once again 23 take away 11, 12. So you could have this solution or 11, 13, 17, 23. Either would be fine. In this question, we need to write the following in order of size, and we're going to start with the smallest. So let's try and work out the values for each of these. 0.3 squared means 0.3 multiplied by itself. which would be 0.09. 0.5 to the power 0 is just 1, since anything to the power 0 is 1. When we have a negative index like this one here for 2 to the power negative 2, we can write it as 1 over 2 to the power positive 2. 2 to the power positive 2 is just 2 squared, so 4, so this is the same as 1 over 4, or a quarter. In a similar way, 5 to the power negative 1 is 1 over 5 to the power positive 1, or just 1 over 5. If we write a quarter as a decimal, it's 0.25, and a fifth as a decimal is 0.2. We can now see the smallest one must have been 0.09, which was 0.3 squared. The next smallest is 0.2, which was 5 to the power negative 1. Then it's 0.25, which is 2 to the power negative 2, and finally 1, which was 0.5 to the power 0. In this question, Lydia is going to pour a drink from the full bottle to fill 7 of the empty cups, and we need to work out how much drink is left in the bottle. So let's start by working out the capacity of 7 of the empty cups. Each empty cup has 1/4 of a litre, and we're going to fill 7 of them, so we can multiply this by 7. To multiply these, we'll rewrite the 7 as 7 over 1, and then multiply 1 and 7 to get 7, and 4 and 1 to get 4. So the amount of drink needed to fill 7 of these cups is 7/4. The bottle starts off being full with a capacity of 2 1/3 litres, but we're going to pour out 7/4 of a litre to fill up the empty cups, so we need to subtract 7/4 from this. To do this, we'll convert the mixed number 2 1/3 into an improper fraction. We can do this by multiplying 2 and 3, which is 6, and then adding 1, which is 7, so 2 1/3 is the same as 7/3. And then we need to subtract 7/4 from this. These two fractions have different denominators, which means we can't subtract them straight away. We need to convert them to have the same denominator. The lowest common multiple of 3 and 4 is 12, so we can rewrite both of these as something over 12. To get from 3 to 12, we would multiply by 4, so we would multiply the 7 on the top by 4 as well. 7 4s are 28. So 7/3 is the same as 28/12. For the second fraction, to get from 4 to 12 you multiply by 3, so 7 times 3 is 21. So 7/4 is the same as 21/12. We can now subtract them because they both have the same denominator of 12. To do this, we do 28 subtract 21, which is 7, and the denominator stays at 12. So the answer to this question is 7/12. In this question, we have Peter, Ray, and Winston that are going to share some money. We're told that Peter has 40% of the money. So if we start with 100% and subtract Peter's share of 40%, we find there's 60% left over for Ray and Winston. Ray and Winston share this money in the ratio 1 to 3. So let's write out a ratio table for 1 to 3 for Ray and Winston, and include a total column. The total number of parts here is 4, since if we add 1 and 3 together we get 4. The 60% that they have represents their total share of the money, so we'll write 60% underneath this 4 parts. Then we need to consider how we get from 4 to 60. That would be multiplied by 15. So we can also multiply the 1 and 3 parts by 15. 1 15 is 15, and 3 15s is 45. So we find that Ray receives 15% and Winston receives 45%. The question asks us to work out the ratio of Peter's money to Ray's money to Winston's money. So let's write out P to R to W. We were told that Peter receives 40% of the money, and we just worked out that Ray receives 15 and Winston receives 45. To write this as a ratio, we don't need a percentage sign, so it must be 40 to 15 to 45. The question does say to give this in its simplest form though, so we're going to need to simplify this. We can divide them all by 5. 40 divided by 5 is 8, 15 divided by 5 is 3, and 45 divided by 5 is 9. So the ratio is 8 to 3 to 9. In this question, we're told the numbers x and y in standard form. For the first part, we need to work out the value of 2x, which is 2 multiplied by x. So if we multiply 2 by the number x, which is 3.6 times 10 to the power negative 3, this is all we need to work out. To do this, we can do 2 multiplied by 3.6, which is 7.2, and then multiply this by 10 to the power negative 3. Now this number's in standard form, but the question says to give your answer as an ordinary number. If you multiply a number by 10 to the power negative 3, that's like dividing it by 10 3 times. So let's take 7.2 and divide it by 10 once, which is 0.72. A second time would be 0.072, and a third time 0.0072. So that's the answer to the question. In the second part, we need to work out the value of y to the power 3, which means taking y, which is 5 times 10 to the power 2, and multiplying it by itself a total of 3 times, so a second time and a third time. To work this out, we could multiply all of the 5s, 5 times 5 times 5 is 125, and then multiply the 10 to the power 2s. When we multiply like this, we would add the indices, so 2 plus 2 plus 2 is 6, so this is 10 to the power 6. Now this question says to give your answer in standard form, and this number is not in standard form yet. When you write a number in standard form, the first part must be a number between 1 and 10, and 125 is clearly bigger than 10. So we need to divide this 125 by 100 to get 1.25. But we can't just do that without changing the power. Since we've divided the number by 100, we must multiply the power by 100 to keep things the same. If you multiply 10 to the 6 by 100, its power will increase by 2, since 10 squared is 100. So instead of 10 to the power 6, it will be 10 to the power 8. For this question, we're going to express the area of circle A as a percentage of the area of circle B. So let's just work out the area of each of the circles first. To work out the area of a circle, you use pi times r squared, where r is the radius. The radius of the first circle is 3 centimeters, so we would do pi times 3 squared. 3 squared is 9, so if you do pi times 9, you get 9 pi. For the second circle, we've been given the diameter at 10, but the radius will be half of this, which is 5. So for this circle, we do pi times 5 squared. 5 squared is 25, and pi times 25 is 25 pi. Now to express the area of circle A as a percentage of the area of circle B, we're first of all going to write it as a fraction. So circle A's area as a fraction of circle B's area, which would be 9 pi over 25 pi. Here the pi's will cancel, so it's just 9 over 25, and now we want to convert this to a percentage. I know that 25 goes into 100 4 times, so if I multiply it by 4, I get 100. If I then multiply the 9 on the top by 4, I get 36. So these two fractions are equivalent. 36 over 100 is just the same as 36%, so the answer must be 36%. For this question, we have several probabilities relating to a Venn diagram, and we need to decide if they must, could, or cannot be true. Let's start with this one here, the probability of A equals 30 over 50. Well, we're told the diagram represents 50 items, so it makes sense that it has a denominator of 50. But can the numerator be 30? Looking at the diagram, we can see we've already got 10 items here, and 20 items here. So 30 items are already in the diagram, which leaves 20 more to be assigned. So is it possible for this probability to be true? Well, the probability of A would come from the numbers inside this circle here. We can see we've already got 10, so can we get 30? Well, to get 30 as the total, we need to place 20 here in the section that's A only. Is this possible? Well, if you add together all of these numbers, 20, 10, and 20, you get 50, which is how many items there were. This would simply mean there'll be 0 outside. So it is definitely possible for the probability of A to be 30 over 50. It would look like this. But must it be true? Can we create an example where it's not 30? Well, yes, there are many ways of doing this. If we place 10 in the section that's A only, we'd have 10 and 10 and 20, so that's 40 items, leaving 10 more for the outside. In this example, the A circle now contains 20 items, so the probability would be 20 over 50. So whilst this one can be true, it also may not be true, in which case we would need to tick it could be true. For the next one, we're looking at the probability of B. The probability of B will come from the numbers inside the B circle. We can see inside this circle there's 20 and 10, so that's a total of 30. So the probability of B must be 30 over 50, since we can't change these numbers, in which case it cannot be 20 over 50, so we would tick cannot be true. For the next one, we're looking at the intersection of A and B with the probability of 10 over 50. To find the intersection, we look at the overlapping section here, which has 10 items. So the probability of this must be 10 over 50, so this one must be true. For the final one, we're looking at the union of A and B, which would come from the numbers inside all of the parts of the circles. At the moment, we can see we have 10 and 20, so that's a total of 30, so would it be possible for all of these numbers to add up to 30? Well, it would, we would just have to put 0 in the a only part here. Is this possible? Well, yes, we could place 20 in the outside and we still hit our total of 50. So this one certainly could be true, but must it be true? Well, not necessarily. We could change both of these numbers to be 10 and we'd still end up with 50 in total, but now the union would be 10 and 10 and 20, which would be a total of 40 over 50. So this one could be true. For this question, we need to solve an equation that's already been factorized. To find its solutions, we consider the first bracket being equal to 0 and then the second bracket being equal to 0. So 3x plus 1 equal to 0, and then also 2x minus 5 being equal to 0. To solve the left equation, we'll subtract 1 from both sides. On the left side, the 1's will cancel, so we just have 3x, and on the right side, 0 take away 1 is negative 1. Then we divide both sides by 3. 3x divided by 3 is just 1x, and negative 1 divided by 3 is negative 1/3. For the right equation, add 5 to both sides. The 5's will cancel on the left, so we just have 2x, and 0 plus 5 on the right is 5. Then divide both sides by 2. 2x divided by 2 is 1x, and 5 divided by 2 is 2.5. So we end up with these two solutions, x equals negative 1/3 and x equals 2.5. For this question, we need to write down the equation of a circle. When we have a circle that has its centre at the origin, its equation is always in the form x squared plus y squared equals r squared, where r is the radius of the circle. We can see from this diagram that the radius of the circle is 9. So let's replace r with 9. So it will be x squared plus y squared equals 9 squared. 9 squared is 81, so the equation is x squared plus y squared equals 81, and that's the answer to the question. In the first part of this question, we need to use the graph to estimate the median speed. We can see from the cumulative frequency diagram that the cumulative frequency goes up to 80. This means the median will be at half of this, which is 40. So we find 40 on the cumulative frequency, go across to the curve, and then down to read off the median internet speed. So that's this speed here, which is at 230. For the second part, we need to use the graph to estimate the interquartile range. To do this, we need to work out the upper and lower quartiles. To find the lower quartile, we would go 1/4 of the way up the cumulative frequency, and 1/4 of 80 is 20. So we find 20, go across, to the curve, and then down, and read off this value here. This one is at 185. Then we need the upper quartile, which is 3/4 of the way through the cumulative frequency. So we do 3/4 of 80, which is 60. So we go from 60 across to the curve and then down, and read off this value at 275. To find the interquartile range, we then do the upper quartile, 275, subtract the lower quartile, 185. And if you subtract these, you end up with 90, which is the answer to the question. In the second part of the question, we need to work out the percentage of the customers sampled that have an internet speed over 300. So this time we start with the internet speed 300, go up to the curve and then across to read off the cumulative frequency, which is at 68. This means that 68 of the customers have an internet speed up to 300, but we want to know how many have an internet speed more than 300. So what we want to know is how many customers are there from this value of 68 up until the final customer, the 80th one. We can work this out by doing 80 subtract 68, which is 12. So 12 of the customers had an internet speed over 300. But the question says what percentage of the customers is this? So let's write it as a fraction. It's 12 customers out of all 80 of them. And to write this as a percentage, we'll divide both of these by 4, which will give you 3 over 20, and then multiply both of these by 5, which will give you 15 over 100. And 15 over 100 is 15%. So the answer is 15. In this question, we need to work out the size of angle ABC. Since the line AC is a diameter, we can use a circle theorem, and you should know that this angle is always a right angle. So the answer is 90 degrees. In this question, we're told that y is directly proportional to the square of x, which means that we can write an equation y equals kx squared, where k is some constant number that we need to find. We then need to work out the equation connecting y and x, which means we need to find what this k value is. We can do this using the graph we've been given. If we look at the point that has an x value of 10, and check its y value, we see it's 500. So if x is 10, y will be 500. So let's take our equation, y equals kx squared, and substitute in these values of 10 and 500. So y equals, which is 500 equals, k times x squared, which is 10 squared. 10 squared is 100, so we have k times 100, which is 100k. We can now solve this equation by dividing both sides by 100. 500 divided by 100 is 5, and 100k divided by 100 is just 1k. So we find that k must have been equal to 5. So if we take the equation y equals kx squared, but change the k to a 5, we get the answer. Y equals 5x squared. In the second part of the question, we need to work out the value of y when x is 20. So we take the equation we just found, and we're just going to substitute x for 20. So y equals 5 times x squared, which is 20 squared. 20 squared is 400, so it's y equals 5 times 400, and 5 times 400 is 2000. So y equals 2000. In this question, we're told about the triangle ABC, which is reflected in the line x equals 1, and we need to work out how many of the vertices are invariant. The line x equals 1 is a vertical line that goes through 1 on the x-axis. So let's take the triangle and reflect it in this line. We just need to work out how many of these points stayed in the same place. Well, if we look at point B, that moved over to here, so that definitely didn't stay in the same place. Point C also moved, so that's not in the same place. But point A stayed in the same place because it's on the mirror line. This means it's an invariant point. So only the point A was invariant, so the answer is 1. For this question, we need to work out the values of x and y. Let's go for x first. The trick with this question is to rewrite both sides of this as powers of 2. You should know that the square root of 2 is the same as 2 to the power 1/2, since anything to the power a half is the square root of that number. On the left-hand side we have 4, which is 2 squared, since 2 times 2 is 4. So let's rewrite the 4 as 2 squared. So we have 2 squared to the power x. When you have a bracket raised to another power, you can just multiply the powers together. So this is the same as 2 to the 2x. Now we've written both sides as a power of 2. 2 to the 2x equals 2 to the half, which means the powers must be equal to each other. So 2x must equal 1/2. Now we just solve this by dividing both sides by 2. 2x divided by 2 is 1x, and 1/2 divided by 2 is 1/4. So x must have been 1/4. Now let's try and find y. In this one here we have 2/3 to the power y is equal to 1.5. The trick here is to realise that 1.5 is the same as 3/2, since half of 3 is 1.5. Now you might notice that these fractions are the same, but one is the reciprocal of the other, which means the power of y must have been -1, since when you have -1 as a power, you can just take the reciprocal. So the answer is y equals -1. In this question, we need to write 0.72 recurring as a fraction. We'll start by saying that x is equal to 0.72 recurring, which is 0.722222, and so on. Then we'll multiply this by 10 to get 10x is equal to 7.2 recurring. And we're looking for all of the numbers after this decimal point to line up, and they almost do on this one, we just have this 7 and 2 which don't line up. So we'll multiply by 10 once more to get 100x, which is 72.2 recurring. We can now see that if we use the 10x and 100x, all of these numbers here match, they're all 2's, so we can use these two to convert this to a fraction. So let's ignore the bottom one, x equals, and we'll just use the 100x and 10x, and we're going to subtract these. If we do 100x subtract 10x, we get 90x. And then on the right hand side, if we do 72 subtract 7, we get 65. And everything after this decimal point will go to 0, so it's 65.0000 or just 65. So we end up with 90x equals 65. If you divide both sides of this by 90, on the left 90x divided by 90 is 1x, and on the right 65 divided by 90 is 65 over 90. So x must be equal to 65 over 90. The question says to give your answer in its simplest form, so we can actually simplify this by dividing both by 5. 65 divided by 5 is 13, and 90 divided by 5 is 18. So it's 13 over 18. For this question, we've been given the graph of y equals sine x, and we need to work out the coordinates of the point P. So let's first of all work out the x coordinate of point P, which is this one here. You can see that between 0 and 90 we have 3 squares, which means each one of these squares must be 30. So the x coordinate is 30 degrees. But what about the y coordinate? Well, to do this, we can just substitute 30 into the equation of the graph. Since y equals sine x, we just need to do sine of 30. And this is one of those exact values you need to know. Sine of 30 is equal to 1/2, or 0.5. So the y-coordinate is 0.5, and the coordinates of p are 30, 0.5. In the second part, we need to draw the graph of y equals sine of x minus 60. If we treat the original graph, y equals sine x, as f of x, then we could write f of x equals sine x. We've been asked to work out f of x minus 60, since that will be sine of x minus 60. When we subtract a number inside the bracket here, this means we're going to do a translation, but it's typically the opposite of what you would first expect. Rather than going to the left 60, this one will go to the right 60. So we just need to take each of the key points of this graph and move them to the right 60 degrees. So let's mark on some points, and we'll move this first one 60 to the right, and then the second one 60 to the right, and then the third one, and the fourth one, and let's just move all of these points 60 degrees to the right. You'll see that a couple of these go off the graph, so we don't need those ones, and we can join these up with a nice smooth curve. But there is a section to the left of the first point that we do need to add on. The question says to go from 0 to 360, so we just need to go back and add this part in here. For this question, we've been told some information about 4 of the sides on this diagram. So let's add these on. AD is 4x minus 2, DE is 10 minus 2x, BD is 2x plus 3, and CE is x plus 9. We need to work out the value of x. What we're going to do is look closely at this triangle here, triangle ABD. If we take that triangle and draw it over at the side, we know 2 of its lengths. AD is 4x minus 2, and BD is 2x plus 3. Now we're going to look at this larger triangle here, triangle ACE. If we draw this one at the side, we know the base of the triangle CE, that's x plus 9, but we don't yet know the length from A to E. To get from A to E, we must go along AD and DE, so we need to add together these 2 lengths. So to get the length from A to E, we would take the 4x minus 2 from A to D, and the 10 minus 2x from D to E, and add them together. If we add these together, we've got 4x take 2x, which is just 2x, and negative 2 plus 10, which is positive 8. So the length from A to E is 2x plus 8. Due to the way this diagram has been drawn with the parallel lines, we know that triangle ABD and triangle ACE are similar triangles. This means if we divide their corresponding lengths, they must be equal. So if we take AD and AE and divide those, this must give us the same result as if we took BD and CE and divided those. So we end up with this equation here, which we can solve to find the value of x. To do this, we're first of all going to multiply both sides by 2x plus 8. On the left-hand side, this will cancel the 2x plus 8 on the denominator, so we'll just be left with 4x minus 2. On the right-hand side though, we'll have 2x plus 3, multiplied by this 2x plus 8, still divided by x plus 9. Now we can do the same thing with x plus 9, so we multiply both sides by x plus 9. On the left, we'll now have our 4x minus 2 multiplied by this new bracket, x plus 9, and on the right, the x plus 9s will cancel, so we just have 2x plus 3, 2x plus 8. Now we need to expand both of these sets of brackets. On the left-hand side, we have 4x times x, which is 4x squared, 4x times positive 9, which is positive 36x, negative 2 times x, which is negative 2x, negative 2 times positive 9, which is negative 18. We can simplify these x terms here. 36x take 2x is 34x. So this is the left-hand side. We'll do the same idea on the right-hand side. 2x times 2x is 4x squared, 2x times 8 is 16x, 3 times 2x is 6x, and 3 times 8 is 24. Once again, we can simplify these two terms. 16x plus 6x is 22x. So now we have this equation to solve. We can subtract 4x squared from both sides. This will cancel the 4x squared on the left, so we just have 34x take 18, and also cancel the 4x squared on the right, so we just have 22x plus 24. Then we could subtract 22x from both sides. On the left, 34x take 22x is just 12x, so it's 12x minus 18, and on the right the 22x will cancel, so it's just 24. Then we can add 18 to both sides. This will cancel the negative 18 on the left, so we have 12x, and on the right 24 plus 18 is 42. Then we divide both sides by 12 to give us x equals 42 over 12. This fraction will simplify. We can divide both of these by 2 to get 21 over 6. And then if we write this as a mixed number, 3 6s go into 21, that's 18, so there must be 3 more left over, and the denominator is 6. So it's 3 and 3 over 6, but 3 over 6 simplifies to a half, so it's 3 and a half, or 3.5. In this question, we've been given two functions, f and g, and we need to prove algebraically that fg of x is greater than or equal to -1 for all values of x. To start this one off, we'll work out what the function fg of x is. To work out a function like fg of x, we start with the f function, so that's x squared minus 2x, and then we substitute in the whole g function wherever there's an x. So we're going to replace all of these x's with x plus 3's because that's what the g function is. So let's replace the x in the x squared with x plus 3, and importantly here we need to put this in a bracket, and let's also replace the x in the 2x with x plus 3, and once again we'll use a bracket. So this is the function fg of x. Let's do some expanding. X plus 3 all squared means x plus 3 multiplied by itself. So this is what we really have. So x times x, x squared, x times 3, 3x, 3 times x is also 3x, and 3 times 3 is 9. And if we simplify these, 3x plus 3x gives you 6x. Then for the second bracket, negative 2 times x is negative 2x, and negative 2 times positive 3 is negative 6. We can simplify once again here, we've got x squared, and then 6x minus 2x, which is 4x, and then we also have 9 subtract 6, which is 3. So we end up with this, x squared plus 4x plus 3. So how do we show that this is greater than or equal to -1? Well, the way to do this is to complete the square. To complete the square, the first thing we do is look at the coefficient of x, which is this 4 here. We then half that number, so half of 4, which is 2. This tells us the number that will go inside the bracket, so it will be x plus 2 all squared. We then square this number, which happens to give you 4, and subtract that from the bracket. And then we just bring down this plus 3 here. There's one more thing to do, we need to simplify these numbers, so -4 plus 3 is -1. So this is now in the completed square form. And why does this show that it's greater than or equal to -1? Well, this part here is just a square number. Whatever value you substitute in for x here, you're going to do something squared. When you square a number, it can never give you a negative result, since when you square a positive number, it will be positive, and when you square a negative number, it will also be positive. In fact, the lowest value this bracket could possibly give is 0. If x were -2, we'd have -2 plus 2, which is 0, and then 0 squared, which is 0. So this bracket must be greater than or equal to 0. Which means the whole expression here must be greater than or equal to -1, since we do 0, take away 1, which will give you -1. So we might write some concluding statement, for example, x plus 2 all squared is greater than or equal to 0 for all values of x. Which means that x plus 2 all squared subtract 1 is greater than or equal to -1 for all values of x. And now on to the final question. In this question, we need to work out the exact area of triangle ABC. We're going to start by looking at the triangle ABD. It will be helpful if we can work out the length of side AB, so we'll call that A. And if we're going to call this lowercase a, the angle opposite it must be capital A. The side AD, which is square root 6, could be lowercase b, and the angle opposite that would be uppercase B. We can now use the sine rule here to work out the length of AB, which we've labelled as lowercase a. So the sine rule looks like this, where we have A, which we've just called A, over sine of capital A, and we've got capital A as 45, equals B, which is square root 6, over sine of capital B, which we've got as 60, so sine of 60. Sine 45 and sine 60 are some exact trig values you need to know. Sine of 45 is the square root of 2 over 2, and sine of 60 is the square root of 3 over 2. So we end up with this. We have a divided by square root 2 over 2, which is a divided by a fraction. It might be easier to write it like this. A divided by square root 2 over 2. And on the right hand side we can do the same idea, square root 6 divided by square root 3 over 2. I've also wrote the a and the square root 6 over 1 so that they're both fractions. Now we have to divide some fractions, and we know how to do this. We change the divides to multiplies, and then take the reciprocal of the second fraction. We can now multiply these. On the left hand side, a times 2, that's 2a, and 1 times root 2 is just root 2. On the right hand side, root 6 times 2 is 2 root 6, and on the bottom, 1 times root 3 is root 3. If we divide both sides here by 2, that will cancel the 2's on the top of each of the fractions, so we just have a over root 2 equals root 6 over root 3. If we leave the left-hand side the same, the right-hand side is square root 6 over square root 3, and there's a third rule that says this is the same as the square root of 6 over 3. And 6 over 3 is just 2, so the right-hand side is just square root 2. Now we can multiply both sides by root 2. On the left-hand side, this will cancel the divide root 2, so we just have a, and on the right-hand side, we have root 2 multiplied by another root 2. When you multiply root 2 by root 2, you just get 2. So we found that a must be equal to 2. So let's update our diagram and replace the a on the left-hand side with 2. The next thing we're going to do is work out some angles. We'll start with this angle here. This angle must go with the angle that's 45 degrees to make 180, since these are angles on a straight line. So if we do 180 subtract 45, we find this one is 135. Then if we look at the triangle ADC, we can work out this angle. All three of the angles in this triangle must add up to 180, so if we add the two we have, 135 and 30, we get 165. And then if we subtract that from 180, we find this angle is 15. Then if we do the same idea with the other triangle ABD, to find this angle. So 60 and 45 is 105, and if you take this from 180, you get 75. So this angle is 75. Now, if you add 75 and 15, you can find the whole angle there, which gives you 90. So this must actually be a right-angled triangle. Since this triangle is right-angled, we can then use SOHCAHTOA to find the length of AC. So if we take this 30 degrees here to be our angle, then the AC side must be the adjacent, and the AB side must be the opposite. So we can write down that tan of 30 must equal the opposite, which is 2, divided by the adjacent, which we don't know. Tan of 30 is yet another value you need to know. It's 1 over square root 3. Since both sides of this equation are fractions, we can take their reciprocals. So we end up with this. Square root 3 over 1 is just the same as square root 3, and then we can find the adjacent by multiplying both sides by 2. On the left-hand side, 2 times root 3 is 2 root 3, and on the right-hand side the 2's will cancel, so we just have the adjacent. So the adjacent was 2 root 3, which is the length from A to C. Now that we have the base of the triangle at 2 root 3 and its perpendicular height at 2, we can find out its area by doing 1/2 multiplied by the base, which is 2 root 3, multiplied by the perpendicular height, which is 2. Which is 1/2, and then if we multiply 2 root 3 by 2, we get 4 root 3. And then if we do half of 4 root 3, we get 2 root 3. So the area of the triangle must be 2 root 3. And you can see this matches the form we were asked for in the question. Thank you for watching this video, I hope you found it useful. Please subscribe so you don't miss out on my future videos, and I would also appreciate if you could like, comment, or share this video with your friends.